Hi there, everyone. This is Ritik again, and I'm here to describe you what progress I made in my project. So earlier in the video, we saw like I deployed some infrastructure on AWS using Terraform, and that infrastructure consisted of an EC2 instance, a virtual private cloud, and we also had subnets and security groups in that. Let me just show it to you in a jiffy. Just a second. There you go. I think it was in the project. These are my learnings actually. So just give me a second. Where is it? Yeah, no. That's weird. Where did I with my project? Oh yeah, I think it was in over here only in this directory. So yeah, we basically deployed an EC2 instance, and these are the main Terraform files that we created. I described everything in the last video, and then I also deployed an Elastic Container Registry or the repository using Terraform as well. So as you can see, uh, I can show the repository to you from here, my AWS account, ECR. First of all, this is a container that I launched, okay? And ECR repository would be here, my repository. So yeah, I just like made I added one more E in order to make it unique. So yeah, that's the prerequisite of from AWS, that you have to have a specific and a unique repository name while you're launching it. So that's why I just Mori in over here. So yeah, as you can see, we have our base infrastructure ready. So after I got my base infrastructure ready, I actually opened my terminal for the EC2 instance that we created or launched. And just give me a second. How do I actually move it? Okay, that's weird. I just have to minimize this and then I'll show. So here, as you can see, this was our EC2 instance that we launched. And after launching our EC2 instance, I had to install Java in it. And then I had to install Jenkins and then Docker. And after I installed everything, I gave the proper permissions and opened the port. And everything was mentioned in the security group that I deployed via my Terraform code. So all we had to do was install certain softwares like Java, Jenkins, and Docker, and then giving permissions for the services to be used by each other, that is, providing appropriate commands in order to give the permissions for Jenkins to access and use Docker. After we did that, we simply could access our application using the public IP, which is over here. This is the same public IP. And out here, I created a pipeline. I'll just describe it to you how I did that. And basically, when we started with Jenkins, we actually installed certain plugins, which were namely Docker pipeline. And let me show that to you. Where is it? Okay, yeah, I remember I uninstalled it because I actually didn't use it. So I just installed the Docker plugin and then the ECR plugin as well, but I later uninstalled it because I wasn't really using it. I simply gave the command line basically gave the command through the terminal after SSHing into the machine. So after that, after the plugins, like if you want to simplify your code, you can actually use plugins, but I actually didn't use it because my Jenkins machine was getting really heavy. So that's why I actually uninstalled the plugins. And then we set up some credentials. This one was for accessing the GitHub account. This is the username and password type secret. And in over here, there is another GitHub secret which only has the token. Uh, it's a secret file secret text kind of secret, and this is the username and password type of secret. And we would be using this in the Jenkins file that I will show. So basically out here, as you can see, this was my repository, and we have our source code out here. We have a Docker file, Jenkins file, and certain package.json in order to uh, populate our environment with the right amount or right kind of dependencies or whatever we want to install in order to run the application. So out here, I can just show you the Docker file really quick. So in here, I have actually used a multi-stage Docker build, and what it does is it actually uses certain, what should I say? There are certain principles which Docker use, which helps us to minimize the size of the image. So basically, what happened was initially when I just wrote a simple Docker file, it was somewhere around of 450 MBs. And then when I actually wrote the Docker file and by using multi-stage, which is, as you can see, this is one stage from here to here, and then we are using this image that we built in our stage one in stage two. So what it does is it only fetches the executable file that we are running out here using npm run build, and then we use only this executable into our image, which basically minimizes it up to 90%, to be honest. And this image is really somewhere around like 45 or 50 MBs in size. So that's the beauty of Docker. We can also use distroless image out here, but I actually didn't use it. But it is a great advantage to actually use distroless image. So distroless images are also a way of minimizing the size of Docker file. And what it really does is a distroless image actually contains only the necessary packages or the tools that you really need in order to run the application. So imagine if I have a server which only has the application running in it and the dependencies it need in order to run it, rather than installing the dependencies like net tools, not the dependency, rather than installing the other tools like debugging tools or network package managers or any command line tool that we actually use in our terminal. So we don't really use that. So Google has given us some Docker images, distroless Docker images, which we can use, which only holds the base, like the minimal environmental tools that you really want in order to run and deploy the application. You can't really debug it. There are upsides and downsides to it, but it is really more secure because since there are no debugging tools, you can't really access it, right? So that's the beauty of it. And also, there's a silver lining, right? Silver lining with a touch of gray. That's what I can say. So yeah. Then moving ahead, so this was my Docker file. This is my Jenkins file. So basically, what I did was I actually made a pipeline, and the agent was any environment. I actually declared some environmental variables, which was my registry name. This is basically the registry name or the repository name for my ECR registry that I have on the AWS cloud. As you can see, this is the entire link for that. My name of the repository is my repo, and this is my account key, and then there are certain like data types that basically is given to us by AWS. So if I just check it out here, if I just view the push code commands, you can see out here we have to log in first, and then we can tag our image using this. So basically that is what we have done out here. After we specified the registry, we would be using it later in order to push and pull our image from the ECR repository. ECR, yeah, that's it. So this is the build number. Build number is like whenever we run a job in the pipeline, it has a build number associated to it so that we can identify which build number it was, and that's what we are fetching it, and we'll be using it later in our code. So we have stages. We have build image, where we are actually just running a script in order to build the Docker image. And here I am using the tag registry and build number in order to build a Docker image with this tag. So the tag would be Docker images name would be starting from this, and then it would be having a semicolon, and then it would be having the build number. So as I can see, I ran this pipe earlier, and there would be certain images as you can see out here. Let me show you this one. So yeah, here it is. So this is the registry name entirely, and this was the build number that I mentioned out there. And let's go further. We now what we did was, after we actually build our Docker image, we actually want to push it to the ECR. So what command do we have to run out here? It's simple. We first have to do AWS configure in our Jenkins machine so that we are able to log in into the AWS account via the command line, right? So basically what we do is, from the EC2 instance, we actually configure our AWS account uh, using AWS configure. Oh, just a second. And then we mentioned the AWS access key and the secret key. So basically, how you can do that, you can actually create a role for that, and then you can assign that role to a user, and then basically, where what you do in the role is you assign a certain type of policies or permissions to the role, and then you assign that role to the user that you have. So I'm Ritik, and I can show you. I just give me a sec. Let me just show it. You just open I am, and you can see a role out here which I created, which gives full administrator access. This is a role that I created. As you can see, the permissions out here, and I also gave the role to actually, basically, administrator access gives permission to every resource or service there is present on the AWS, so we can access it. But yeah, I also mentioned this. It's not necessary, but yeah, just for my own OCD. So, and then I launched a user, which was Ratek again, and then I assigned the security credentials. I assigned the role to it, and then I actually got the security credentials and the access key from here. This is the access key, and then the secret is actually generated. You can't get it directly from here, but once you generate a basically when you once you generate or like make a role or a user freshly from start, then you actually can copy the secret key from there, and then you can use it to configure your AWS account in your EC2 instance server. So let me just get back over here, and yeah, so let's go. Hold up, let me show it. So here you go. We straight away pushed the image by using the command which was provided to us by AWS, and the commands were shown here. This is my repo, UAV push command. This was the command that we used, and then we straight away pushed our image to the ECR repo. And that's what we did out here. Sorry about that. It's I'm in Canada right now, and it's the flu season, so yeah, that's what happens out here. You have to brace up yourself with proper multivitamins and micronutrients. You have to take care of that. If you don't, even if you do, if you just like go out there in minus 19 or 20 degrees, then you're bound to catch a cold somehow. So yeah, but still you have to take care of yourself, right, with the proper nutrition. So yeah, so let's get back again, and then I push the image. So now after pushing the image, I'm actually updating the deployment file, which is the Kubernetes file out here. So basically what we are doing is we are deploying this file with a new image tag that we'd be using in order to actually run our application later on via uh, continuous deployment, which is called GitOps, using ArgoCD, which would be deployed in an EKS cluster, which I would be showing to you later on. So let's get back. So what it would do is, what our pipeline will do is it will actually update this replace image tag with the build number that we are using in the pipeline. And what we have done out here is we have specified our repo name and also the username, and then with using credentials GitHub secret, which I generated and kept out there in the Jenkins secrets, global secrets, secrets. Yeah. So yeah, we are using that, and then we are configuring our email ID, username, and then we are. This is a command that actually updates our deployment file, and then we are actually using git add in order to like. So this the git command is basically used by the plugin which is stored in Jenkins. So initially, when you install Jenkins, it prompts you to install certain plugins which are essential, not really essential, but it really asks you to, like, if you really want to install it, then you can just go ahead and install that. And in that module, or like in that bundle, you can get the Git plugin. So that's what I'm using out here. Git add, git commit, and then we are pushing it to our repository, which is this, the repository on GitHub. Okay, so yeah. After that, we have a post stage, which is used in order to clean up all the files that we actually made. And we so what error I encountered was my Jenkins earlier when I was talking, when I told that I had to delete certain plugins in Jenkins. What really happened was, like, one of my worker node went off because there wasn't any space available for my agent to run, because everything was populated and I was having hard time figuring it out. And then I actually saw the log, and then it says like the disk space is very low. So I had to check out the disk, and later turns out it was populated with the Docker images that I'm building and pushing in. So what it does is it saves the Docker image somewhere, right? So the Jenkins pipeline saves the Docker image on the server that Jenkins is running on. So yeah, that's how everything was populated onto my server, and it had no space to run the agent on. So that's why I just added this post stage where I'm just deleting all of those images that I had generated uh, after running my pipeline. So here, let me show you the pipeline that I created. This is a CI pipeline, and yeah, I'll just show you the configuration. So what I did was I defined the pipeline and I imported the script, the Jenkins file, through the GitHub after using GitHub from SCM. And here I described Git. So out here, what you have to do is you have to keep this in mind. I actually struggled, not struggled, but yeah, I was like stuck on this for like 5 to 10 minutes. So once you mentioned your URL, you have to specify the credentials. And in order to specify the credential, out here you have to specify the credential which is of username and password type. So the username is this, and the password would be again the token that we would be generating from our GitHub repo, which is from here. We actually go out to the settings, and then we go developer settings, personal access token classic, and that's how we generate our token. So after we generate our token, copy this token and just like add it to the Jenkins. If you don't know how to do that, I can just show it to you really quick. This would be global username and password. This would be the username, and then the password would be fetched from GitHub. So let me just show it to you. Oh, I have to launch a normal classic token. So this could be XYZ, and then yeah, I'm just like skipping it, and then generate a token. This is a token that you would be using. So that's how it works. And then you paste it over here, and then you give an ID which would be mentioned in the pipeline, or this ID would be used by Jenkins in order to fetch this credential, right? So this is a unique identifier in order to fetch their credentials. And then we specify the branch we are working upon, which was main, and then we specify the path in order to in order to find the Jenkins file. So since this is directly in our GitHub repository, we we don't really have to specify a path. But uh, if there was a path like this, Jenkins ArgoCD. So everything we have to mention the path like this. This would be the path for the finding the Jenkins file. So this was a repository which I actually referred, but yeah, I will definitely include this into the description that I would be showing it to you later. And then I applied it, and so let's go. Let's get back, and we try to build the pipeline. You can also add webhooks, GitHub webhooks, but I was so excited that my application ran, so I just wanted to show it to you guys, and here you go. We did it trigger? No. So you can click build trigger, build now in order to run the pipeline. And let's wait for a second. So as you can see, there is a pipeline 29, job number 29 that is running, and then we can go to the output. So out here, we obtain the credentials, and then we were able to fetch or like check out to our repository. And then we had this is basically used for debugging whether I actually used it whether Jenkins is able to access my repository perfectly or not. And then what I did was I actually started using the second stage, which is Docker build, and that's how we build our Docker image. And then later on, we actually SSH into our not SSH, but logged in into our ECR repository, which was a success, as you can see. And then we pushed the image, which would be repository, like the entire URL for repository, and then the build number, which is 29. And then we push the layer, and then later on, we are at the next step where we are actually updating our deployment file and pushing it to the GitHub repo. And out here, this is being configured, and we actually updated a deployment file, and then we added it showed, yeah, everything is done, get push, so it is pushed, and now everything is deleted once our pipeline has been successfully built. So as you can see, this is the thing that I was showing. Oh, everything's done. So I can show you the updated thingy out here. So we were at here, task tracker. Let's see whether our Jenkins file was updated or not. Or not the Jenkins file, the manifest file. So let's see. Initially there was replace tag, and now there is 29. So this was the exact number of our build, which is 29. And so everything is done. So our CI part is done. And now for the CD part, what we did was we actually launched another EC2 instance, and this time we actually we used that EC2 instance in order to deploy an EKS cluster, and then deploy ArgoCD in it, and then use ArgoCD deployed in that cluster in order to deploy our application. How we did that was using these commands. So initially, what do you want in order to run ArgoCD and deploy our application? You need an AWS CLI. So we install that using these commands. As you can see, okay, you can see the version AWS after installing the version, and then we also installed EKSCTL. So EKSCTL is a command line tool in order to interact with EKS cluster and like which is present on AWS. It helps us to create the cluster and like work with it. And then we also deploy kubectl onto it in order to interact with our cluster, which was deployed on AWS using EKS. So kubectl is used in order to interact with the cluster. And once we install that, we run this command in order to deploy our EKS cluster. So as you can see, EKSCTL create cluster, the name would be demo EKS, region is US East 1, and the nodes name is my node. And there are two types of nodes that we are not two types, there are two nodes that we are deploying of t3 dot small type. And then after deploying, we fetch the EKS cluster name. So after this command, it really takes 15 to 10 minutes in order to deploy the cluster behind the scenes, but AWS manages the control plane and everything, and it also provides the worker nodes for us. And now after that, we fetch the name and the worker and whatever is there in a cluster. After that, we are actually connecting our, like, basically we are mentioning that our EKS cluster can be contacted by using kubectl. So that's how we upgrade the kube config file so that kubectl can access the cluster uh, after using this kube config file and SSH, not SSH, but yeah, authenticate with it. And then after that, we actually created a namespace for ArgoCD and deploying ArgoCD. And how we deploy it by is using kubectl command and deploying it as a Kubernetes pod. So out here we are deploying Argo CD over here. And then we define the Argo CD server to be accessed by load balancer type. So basically, we would be able to access the Argo CD cluster using load balancer. And then after doing that, we actually fetch the first initial admin password using this command. And after we were able to do that, uh, you can go out to the load balancer and check uh, a load balancer. So now, right now, there are two, but this is the load balancer which got created when I launched the service. And once you copy that and run Argo CD, not run Argo CD, but enter port 8080 on it, you can see our Argo CD application running over here like this. So let me verify. Hold up. I did not run it. Oh yeah, it was 80. Sorry about that. So yeah, our Argo CD runs on port 80, not 8080. So after we can see that our Argo CD is running, we had to apply the we have to input the password. And once you do that, you basically just have to do new app, and then application name would be XYZ, project name would be default, as you can see, and the sync policy is automatic, auto create namespace, and then you mention the repository URL, which would be task tracker, right? This is a repository, and we can fetch the URL from here, mention it, and the path would be the path for the deployment file would be, let me just show it to you, git manifest. You just copy that and paste it out here, and then the deployment file is in this. So the cluster URL would be kubectl, namespace would be whatever xyz, or you know what, this dev, yeah. And then we do create. So let's see whether our application is being deployed or not. So what it does is it fetches, it basically keeps a track on any changes on the deployment file. So since are we just actually updated. So yeah, I'll just show it to you. So what I did was earlier, I already had this application which was connected. This is the one T which was like correlated and connected to my task tracker. So as you can see, the kubectl, the deployment file got updated with the tag 29, right? So this triggers, basically Argo CD fetches any changes done on the deployment file, and if it sees any changes, it try to sync in with the current state of the deployment file and then relaunches the application. So I'll just show it to you after actually. This is the same infrastructure that is used out here. So let's get back. So T was the earlier application that we deploy, and this was a service. So one more thing, I had this error where I actually got stuck for like more than 25 minutes. So Argo CD basically identifies or fetches the deployment files using a certain terminologies or names. So the deployment file should be deployment.yaml, and there should be a service.yaml separately so that I could understand and fetch it. And then it should be inside a folder, which is basically which could be anything, but it's the deployment files should be inside a folder. So that's how ArgoCD recognizes it. I don't know why, but it's probably it's the file structure that ArgoCD works with. So after I mentioned everything, you can see there were the application was launched, and then as you can see the events. Just let me show it to you, the pod which was created. So if you go back to the events, as you can see the pulling, so basically what it did was like it fetched the change in my deployment file and then it pulled the image from the repository and it deployed it again. So as you can see, uh, everything started out here and schedule started, created, pulled, and pulling. And after we did all that, now basically what we did was we also deployed our application as a service, but the type of service was load balancer type. So basically it would launch another balancer URL, which we can use in order to access our application. So as you can see, the second load balancer that we have one more, since like yeah I deployed another one. So you just have to copy this DNS name, copy it out from here, and our application was running on port 80. So I hope it works because it should. Let's see. Yeah, there you go, our task tracker app, and here you can do uh like whatever you want to add. And then you can manipulate it, you can update it, grocery, and also you can delete it, you can type it done. So that's our basic application out here. That was it. So whenever there would be an update on the deployment file, Argo CD would automatically fetch the changes and then deploy our application and try to sync in with the current state. So here you go. That was the end of it. And I will definitely improve this application more by using SonarQube for static code analysis. I can also use Trivia for Docker image scanning. And I also have to include Jira ticketing, since basically now I would be changing the policies of my repository to a uh, public type. So I, if there is any error or changes, people can comment on it, and then I can actually generate an automatic ticket on Jira. If someone comments on my pipeline or does anything on or like comment, it would generate a Jira ticket for me. And we can also integrate our kubectl Kubernetes cluster, the EKS cluster, with Prometheus and Grafana for having a monitoring tool associated to our cluster so that we can monitor everything. And I will also definitely add on some scripts uh, in order to run on our EC2 instance, which is running our Jenkins pipeline. And we would be deploying a cron type job, and it would be sending our basically the whatever data that we want for monitoring our EC2 instance. We would be using that. Also, I'm thinking, yeah, I feel like that would be it. Yeah, that would be it. And if I find some more improvements into the project, I would definitely integrate it with that. I'll probably end the session now because yeah, I think we are done with that. And every command, everything, I would be describing or like writing that in proper description and in proper detail so that you guys can actually use that as a reference and run your own application, because this project was really helpful in order to and for me in order to understand the core basis and the networking and how an application really works using the CD, which was the GitOps. It was really interesting and thrilling. So I hope this project help the people who are really looking out for something like this. So if you want to reach me out, you can definitely reach me out to the email ID, which I would mention later. I'm not mentioning it right now, but yeah, you guys can definitely reach me out on LinkedIn. And I hope to meet you guys somewhere in the future. Until then, ciao. See you.